Hi, in this course, we are going to look at a important topic in the Olympiad preparation, which is polynomials. And the way we cover this course is through problem solving. So I'll discuss a lot of problems which are taken from various Olympiads, and I'll make a playlist for you guys, which will help you navigate through different techniques that you must know when you want to solve Olympiad polynomial problems. Right? So we start off with the first section, which is on the topic of reciprocal polynomials. So basically, if you have a standard polynomial like this, ad x power d plus some ad minus 1 x power d minus 1 and so on till a naught, which is the constant term, we may try to convert this to a reciprocal polynomial which looks like this: a naught x power d plus so on till ad. So what has happened here? This polynomial, the order of the coefficients has been reversed. So here the highest coefficient was ad, and after that it was ad minus 1, and the constant term was a naught. And here what we have is the highest coefficient is a naught and the constant term is ad, right? So how do we do this transformation? How do we go from p of x, which was equal to this polynomial? So we just have to calculate x power d p of 1 by x. So think about it. If p of x was equal to this, so p of x is equal to ad x power d plus ad minus 1 x power d minus 1 till a naught. What is the value of p of 1 by x? P of 1 by x would be ad 1 by x power d plus ad minus 1 by x power d minus 1 and so on till a naught. And if you multiply this with x power d, what you will get is this x power d gets cancelled, and here there is an x, and here there will be an x power d, right? So you end up with the reciprocal polynomial here, right? So the standard technique in order to go from px to its reciprocal is to calculate x power d p of 1 by x. This is the reciprocal polynomial. We will see applications of these reciprocal polynomials and why this is useful, right? So it can also be given another name, which is an inverse polynomial of p of x. So we'll see some applications of how this becomes useful in problem solving. So for example, first we'll calculate the reciprocal polynomial of some examples. So p of x is, let's say, 2x cubed minus 3x squared plus 1. So let's calculate p of 1 by x. P of 1 by x will be 2 by x cubed minus 3 by x squared plus 1. And the degree of this p polynomial, degree was equal to 3. So in order to calculate the reciprocal polynomial, I should multiply x cubed and p of 1 by x. So when you multiply with x cubed, you will get 2 minus 3x plus x cubed, right? So basically the polynomial that is the reciprocal is x cubed minus 3x plus 2, right? So notice the order of the coefficients here was 2 minus 3 and 1, and now it is 1 minus 3 and 2. So the order of the coefficients has gotten reversed, right? So that is the key criteria for a polynomial to be the reciprocal of another polynomial. Let's take another example. Let's take this particular polynomial. Q of x is equal to 4x cubed minus 3 of x, right? Notice that the degree is 3. So in order to calculate the reciprocal, I should multiply x cubed with q of 1 by x, right? So let's calculate q of 1 by x first. Q of 1 by x will be 4 by x cubed minus 3 by x, and therefore x cubed q of 1 by x would be equal to 4 minus 3x squared. So the polynomial can be written as minus 3x squared plus 4. So again, notice that here the order of the coefficients was 4 and minus 3, and now it is minus 3 and 4. So that is the reciprocal polynomial of this. But notice one thing, the reciprocal polynomial has degree 2 whereas the original polynomial had degree 3, right? So how come the reciprocal had a lower degree than the original polynomial? So basically the idea is that if the original polynomial p of x has degree d such that 0 is a root, 0 is a root with multiplicity r, with multiplicity r, then p of x, which is equal to x power r times q of x, where q of x is not equal to 0, q of 0 is not equal to 0. So what I have done is p of x was degree d, but it had 0 as a root with multiplicity r. So that means x power r can be taken as a factor, right, in p of x as a factor. So what we have done is we have converted p of x and written it as x power r times q of x. And here q of x has no 0 root, right? Q of x is a polynomial with no root being equal to 0. Now, if you want to calculate the reciprocal polynomial for our original p of x, what I have to do is multiply x power d and calculate p of 1 by x, right? So let's see that. So I want to calculate x power d p of 1 by x. And now because p of x can be written like this, p of 1 by x will be written as 1 by x power r q of 1 by x, right? Think about it. P of x could be written like this. So p of 1 by x is 1 by x power r q of 1 by x. So therefore this is x power d minus r q of 1 by x, right? So basically x power d p of 1 by x is equal to x power d minus r q of 1 by x. And therefore this polynomial has degree of d minus r. This polynomial will have degree d minus r, right? So the reciprocal polynomial sometimes can have a lower degree than the original polynomial if it has roots 0 and if the multiplicity of those roots is r, then the degree of the reciprocal polynomial will be d minus r, right? So if you notice the earlier example where q of x was 4x cubed minus 3x, this was 4x cubed minus 3x, and we had here x can be taken common and it is 4x square minus 3, right? So there was one root of q of x which is a 0 root. So when you get the reciprocal polynomial, you got r of x reciprocal polynomial was minus 3x square plus 4. So basically we took the reciprocal polynomial of this and the 0 root doesn't count. So the degree of the reciprocal polynomial came out to be degree 2 because the original polynomial had degree 3 and the multiplicity of 0 was 1. So 3 minus 1 came out as 2, right? So keep this in mind, that always you don't have the same degree of the reciprocal polynomial, right? However, the reciprocal polynomial is always calculated by calculating x power d p of 1 by x. And you have to check what is the degree of this final polynomial in order to get the reciprocal, right? Okay. Now let's look at our first problem for the course. So this is problem number 1. Let p of x be a polynomial of degree 5 with non-negative integer coefficients such that for all x not equal to 0 we have P of x is equal to x power 6 P of 1 by x, and P of 2 is equal to 10 times P of 1. You have to find the greatest possible value, the greatest possible value of P of 3 by P of 2. That is our question. Okay. So on the first glance, it looks like there is no direct approach for this, but we will try to use the concept of reciprocal polynomials here. So first of all, let's say let Px be a polynomial like this. It was degree 5, so we'll say a x power 5 plus some terms plus some constant. This is my polynomial. Now they have said that it has non-negative integer coefficients such that for all x not equal to 0, this condition is true, right? So if c is not equal to 0, then let's look at the polynomial x power 6 p of 1 by x. Let's try to think of this polynomial. So this is going to be x power 6. P of 1 by x will be a by x power 5 plus so on plus c. And notice that this will become a into x plus some terms plus c into x power 6, right? So if c is not equal to 0, x power 6 p of 1 by x is a polynomial like this, which clearly has degree equal to 6, right? But p of x was having degree of 5, right? P of x had degree 5, and here they are saying that p of x must be equal to x power 6 p of 1 by 6. But two polynomials cannot be equal if they have different degrees, right? So degree 5 polynomial p of x cannot be equal to x power 6 p of 1 by x, which is degree 6. Therefore, c must be equal to 0. If c is 0, the last term here will be degree 5, right? So we are getting that c is equal to 0, and therefore p of x is something like this: a x power 5 plus some constant, and there is one last term, let's say bx, right? This is my degree 5 polynomial p of x, correct? So basically now what we can do is p of x can be written as x times q of x, right? Because we can take x common here, and here x, when you take common, you get q of x, which is a x power 4 plus some terms plus b. Notice that q of x has degree 4. So what we are saying is p of x can be written as x times q of x, where q of x has degree 4, right? Great. Let's go on to the next screen and we'll try to work it out. So we are getting p of x is equal to x times q of x. Q of x has degree 4, and we already know that p of x is equal to x power 6 p of 1 by x, right? So basically this is equal to x power 6 p of 1 by x, and what I will do is I will use the fact that p of x is equal to x of q of x. So p of 1 by x is equal to 1 by x q of 1 by x, right? So here I can write x power 6, 1 by x, q times 1 by x, right? So now notice that we are getting from here and here, we are getting x q of x is equal to x power 5 q of 1 by x, and x gets cancelled. You get q of x is equal to x power 4 q of 1 by x, right? And remember that q of x was degree 4 polynomial. So if q of x is degree 4, the reciprocal of q of x, reciprocal of q of x is calculated how? By doing x power 4 q of 1 by x, right? Therefore, this condition means Q of x is the reciprocal of itself. Reciprocal of itself. So think about it. How can a polynomial be a reciprocal of itself? The only way it can happen is if Q of x was written in such a way that the coefficients, even when you reverse the order of the coefficients, they are same, right? So you can write Q of x as a x power 4 plus b x cube plus c x square and then bx plus a, right? Why am I writing it like this? Because here the order of the coefficients is a, b, c, b, a. So even when you take reciprocal, it will still be a, b, c, b, a, right? So this is a property of a polynomial which is a reciprocal of itself, right? So based on this condition, we are able to deduce that Q of x must look like this, right? Because it is the reciprocal of itself. This is for some non-negative integers a, b, and c, some non-negative integer coefficients. So now that we have a characterization of Q of x, we roughly have a characterization for P of x as well, right? Because P of x is x times Q of x. And now we can use the other data that was given in the problem, right? So we can say that P of 2 was equal to 10 times P of 1. That was a data that was given in the problem. And we know that P of x is equal to x times Q of x. And we also know Q of x is equal to a x power 4 plus bx cube plus cx square plus bx plus a, right? So using this information here, we get P of 2 is 2 Q of 2 is equal to 10 times P of 1 is 1 Q of 1. So you get Q of 2 is equal to 5 times Q of 1, right? So what is Q of 2? We can calculate that. Q of 2 will be equal to 16a plus 8b plus 4c plus 2b plus a, which is basically 17a plus 10b plus 4c. So we have 17a plus 10b plus 4c is equal to 5q of 1. 5 times q of 1 is a plus b plus c plus b plus a, right? So 2a plus 2b plus c. 5 times 2a plus 2b plus c. So that is basically 10a plus 10b plus 5c. And 10b gets cancelled here and you get 7a is equal to c, right? So we are getting this condition now, 7a is equal to c. And remember what we wanted to find out in the question? We wanted to find out the greatest possible value of P of 3 by P of 2, right? So now we will work on that. So P of 3 by P of 2 is equal to 3 times Q of 3 by 2 times Q of 2, right? And calculating this 3 times Q of 3 will be 81A and there will be an A here. So it will be 82A plus 27b plus 3b, so 30b plus 9c divided by twice of q of 2, and q of 2 was basically, we had calculated that already. Remember, twice of q of 2 will be 10 times q of 1, right? So we can write, instead of twice of q of 2, we can write it as 10 times q of 1. So I'll write 10 times q of 1 is 2a plus 2b plus c. So instead of calculating with the number 17 and all, I'm just writing it like this, right? So this becomes basically 3 times, since c is equal to 7a, we can use that here. So c is 7a, so this is 63a. So you get total 145a. 145a plus 30b divided by, denominator is 10 times, c is 7a, so this is 9a plus 2b, right? I will do the simplifications on the next page. We are getting P of 3 by P of 2 is coming out to be 3 times 145A plus 30B divided by 10 times 9A plus 2B, right? So this becomes You can cancel a 5, so it becomes 3 times 29a plus 6b divided by 2 times 9a plus 2b. Okay, and on top here we can write it as this is, see, notice that this is 6b, this is 2b, this is 9a, and this is 29. So I can write it as 27a and take a 2a outside. So you get a 6a plus 3 times 27a plus 6b divided by 2 times 9a plus 2b. The reason I have done it like this, split it like this, is because it is a multiple of 9a plus 2b. So if you simplify that, you will get basically 9 by 2 plus 3a by 9a plus 2b, right? And splitting the fraction into two parts, this by this gives 9 by 2 and the other one gives 3a by 9a plus 2b. So you have 9 by 2 plus, divide by 3a up and down, so 3 plus 2b by 3a, right? This is what we are getting, 9 by 2 plus 1 by 3 plus 2b by 3a. Now we had 2b by 3a was greater than equal to 0. Why is 2b by 3a? B and A have the same sign, I think. The integer coefficients, it had non-negative integer coefficients. So I think here we can show that B and A, oh yeah, it had non-negative integer coefficients. Non-negative, right? So basically B and A are positive. So therefore 2B by 3A is greater than 0, right? And because it is greater than 0, greater than equal to 0, what we can say is 9 by 2 plus 1 by 3 plus 2b by 3a will be less than equal to 9 by 2 plus 1 by 3 plus 0. Right? If you divide by the smaller quantity, this is bigger than dividing by a bigger quantity. Right? So this is equal to 9 by 2 plus 1 by 3, which is basically 29 by 6. So you are getting 29 by 6 is the maximum value. We are getting basically P of 3 by P of 2 is less than equal to 29 by 6. And 29 by 6 happens when 2b by 3a is equal to 0 or when b is 0. So if b was 0, the polynomial for us q of x was what? Q of x would have become ax power 4 plus cx square plus a, and therefore that is basically ax power 4 plus c was 7a, so 7ax square plus a, and p of x would have been x times q of x. So that would be basically ax common x power 4 plus 7x square plus 1. This would be your p of x such that the ratio p of 3 by p of 2 is equal to 29 by 6. And if b is not equal to 0, then the ratio is always less than equal to 29 by 6. So basically, the problem was solved by understanding the characterization of p of x is equal to x times q of x. We wrote it as x times q of x because we realized that the constant term of p of x cannot be equal to cannot be non-zero. Constant term of p of x has to be 0 because otherwise the condition p of x is equal to x power 6 p of 1 by x would not be true because the degrees won't match. Once we got p of x is equal to x times q of x, we realized that that implies, along with the condition, it implies that q of x is degree 1.1, q of x has degree 4, and q of x is self-reciprocal. And if it is self-reciprocal, the number of variables in q of x is limited. It has only 3 variables a, b, and c. We wrote a, b, and c. We used the data that p of 2 is equal to 10 times p of 1 to get basically c is equal to 7a. And then we try to find out the ratio of p of 3 by p of 2. And we were able to set up an inequality to figure out the result. Right? So that is one example where the concept of reciprocal polynomials plays a major role in solving the problem. We will continue the series in the next few videos. I will show you many more problems which are going to teach you different techniques of solving problems. This section of the video will cover reciprocal polynomials. So more problems on that are forthcoming. So stay tuned, and if you like the video, please subscribe to the channel and like the videos, comment if you want more such content, and I'll see you next time.